Hello everyone and welcome. My name is Eric Coleman with IIST and I'll be the moderator for today's webinar, Using Artificial Intelligence to Speed Up Your Test Automation Development by Jason Arbin. We're excited you're able to join us today and set aside an hour to attend this webinar. This webinar is sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. This webinar is one of a series of free webinars offered by IIST. Be sure to join us for the next webinar in the series, Accelerate Digital Transformation with Mobile Test Automation, on May 15th from 12 p.m. to 1 p.m. Central Time. To learn more about this and other webinars in this series, go to testinginstitute.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at testinginstitute.com. At the end of today's webinar, you'll be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Jason Arbin. Jason?
Cool, thanks, Eric. Yep. Good morning, or I guess almost afternoon, wherever people are. So we're going to talk about using artificial intelligence to speed up your test automation, and particularly the development of automation. Today, speed is king. Everybody wants to go faster and faster, and testers say, I want to slow things down and provide more coverage. So kind of the happy middle is to actually figure out how we can speed up our test automation development. And AI is a new way to, a new technology. So we'll walk through ways that you can apply AI in ways we have at test.ai to speed up the creation of test automation, and also on the back end, how to speed up or minimize the amount of maintenance that you have to do for test automation. So first question is, like, who am I to be mouthing off about artificial intelligence and machine learning? Those are pretty big, fancy terms. I'll start with saying I'm more of a practitioner. I'm not an AI machine learning genius. The good news is that means that anybody can play with these technologies and tools. So I would, firstly, if you take one thing away from this whole presentation, I just highly recommend you just don't be intimidated by it. Just watch some videos online, take some classes, and you can learn it. Anybody can learn this kind of stuff. So back in the day, I'm an old man. I worked on some of the first versions of Bing, the search engine. And back then, we couldn't keep up with Google, right? So Google had this, had hired every smart search engineer on the planet and every smart search researcher on the planet. And so we figured out, how do we build a search engine? And what we did end up over at Microsoft was using neural nets. So this kind of demonstrates the power of neural networks. So what neural networks let us do was automatically, it sounds like testing and automation, but automatically train neural networks how to do search ranking, right? So instead of having 1,000 engineers, we had just a few engineers, and we'll get into how it works, but and some labeled data, so some examples of good searches, right? Good search queries with good search results. And then we just trained the neural network, and guess what it did? It built a pretty good search engine, right? So I was a test manager back then, and so I go back in the old days to being one of the first test managers on a pretty large neural network, especially for the time. And that was before Google had any AI on their search engine, which is kind of cool. So then I left there. I quit there. I'm a trader and went to work at Google. Most people, I think, in the testing community know me for working on the Chrome test automation. So what I did there was I worked on automating the Chrome browser and the Chrome OS machines, those laptops that everybody has in school these days. And so we did, there was mass scale execution of test cases. And I also had a personalized web search team where we were using AI kind of techniques to personalize web search. So if you were a farmer and you search for trees, you could get pictures of trees. If you were a data scientist or something, you get pictures of data structures if you search for trees. So that's kind of the background. So I've been kind of playing in the periphery around, not even in the periphery, but playing with machine learning and networks for a long time. So I got finally fed up with it all, and I want to just try to automate everything because I'm tired of, I got frustrated with mobile automation, web and mobile automation. It's pretty frustrating. It's hard to get going. It's expensive, and the key thing is very, very slow to write test cases to get stuff up and running. And then what's even more slow is the maintenance of those test cases. So your test case ad rate drops as you have to spend most of your time maintaining these test cases as the applications change. So really, we created test.ai and got money from venture capitalists to just focus on this problem exclusively. That's kind of my context and background on these things. Oh, there we go. So there we go. This is the last slide. I'm kidding. But the one thing to take away is just speed is king, right? And all aspects of it. The cadence of your agile sprint cycles, the ability to deploy, the ability to test, the ability to process and integrate those changes and fixes into the product. Just speed is king for the user, for the company, and for the engineers, and for your own career. So if you look back over the last 10 years, maybe 12 years, what's happened is that everybody else has sped up. QA hasn't, right? Business analysts, developers, PMs, UX folks, they've gotten pretty fast. They've got new tools, new techniques, new approaches to developing and designing and deploying software. And if you look at it, we're still doing QA much the same we did, 10 or 15 years ago. I'm not the only one that says this. And even if you look at modern tools like, Appium and stuff, they very much look the same. They very much have the same positive and negative attributes. We've basically been doing the same thing. So everybody's sped up around us in the organization, and QA is still doing the same old thing. If anything, you could almost argue that we're doing worse because testers aren't testing as much anymore because they're so busy verifying each new build. So the question is, how do we speed up QA, and particularly QA automation? So what's so slow about QA, right? First is that if you think about it, there's manual testing. Manual testing we just know is slow, right? It's because we have humans, and humans don't operate as quickly as a machine. So everybody kind of these days understands the value that if you could automate it, it sounds like a really good idea, right? Because machines could execute hundreds of tests in the time that a manual tester could execute them. And also machines are good at doing things that are very repetitive, right? People and humans get bored. They miss bugs because they get glassy-eyed seeing the same screen, same tests, day in and day out. So it'd be a great thing to automate those things. The problem is that when you get into test automation, they're super slow to write, right? And it goes even to more than just writing the test cases and authoring them. A lot of times, a lot of organizations, the QA folks don't know how to code, right? So how long do you think it takes to teach someone to program? By the way, let alone teach them to program well, right, and reliably. So you're looking at months, right, of just training, sometimes years to become proficient. So there's a really big slow point in creating test automation. Even organizationally, it's very slow and difficult to hire test automation engineers. They're a rare unicorn. I kind of call them like these unicorns of test, right? They care about testing, they can program, and they want to stay in the testing environment. So it's really even slow to hire and find these folks because they have to be able to code. And then also, it's expensive to just write these things. It takes days sometimes, right, to write a test case. And that's iterating on finding the elements to add to your code, a couple of days to debug it and interact with, and then you deploy it, and you have to debug all the brittleness in production. It's a real slow process. And then as you add more test cases, right, you have to maintain those. So if you have 30 test cases and half of them break because the application changed, you have to spend time fixing half of those test cases. And when you finally get to 200 test cases, guess what happens when your tests break? Now you have to fix 100 test cases. So you get these diminishing returns over time, and that just net slows down our ability to add more and more test coverage. So some little more notes on speed. What's interesting is that testers don't test anymore. And I wrote a little blog post on LinkedIn the other day about this and got a lot of drama posts. Most people are pretty positive, and they agree with it. The question is what to do about it. But what's happened, I'm an old dog, and so when I got out of school, we actually tested code, right? When I got out of school, 80% of my time was trying to find bugs, trying to find extreme edge cases, interesting scenarios where we'd have data loss, crashes, functional problems. But these days, because the world is sped up around us, all these other disciplines are shipping fast, creating software, shipping it, and redesigning it faster than we can keep up with it. We have to spend about 80% of our time today verifying that it just works. As we get a new build every day or every week, all of our time is making sure that functionality still works. We don't have any time to test. So what speed would bring and will be bringing to, we'll talk about how to do it, but what speed will bring to test organizations is really giving us the time to get back to finding those that kind of core of what we do as testers, which is as human testers, is find the edge cases, understand the user experience, understand the business needs, and try to find out where the software fails, right, so we can fix it. So today, because this test automation process is so slow and brittle, we just don't have time to test anymore. We spend all of our time updating a small number of automated tests instead. So this slide, I don't know, of course there's Trump. Everybody's got to have Trump in a slide deck these days, but that's him back in SNL, I guess. But this, if you look at the testing tools of today, they really haven't changed since all this stuff was cool. This is how testers look like in an application, an app team in an organization today, right? They're using the latest, like DevOps are using all these log analytics tools and A/B fighting and feature gating and all this stuff. Developers are using new and better IDEs, even new languages. And guess what testers are using for the web today? Selenium, right? What are we using for mobile apps? Appium, which is basically Selenium. So the world just really hasn't changed. So when you think about the current modern test automation tool set, realize you're using the equivalent of like this Nokia phone, right? So it should be obvious to us that it's probably about time for change. It's probably about time that we reassess how we automate and how we speed this stuff up. And then lastly, a quick thing is, why do we need to speed this up overall? We feel like we need to speed it up. We want to add test cases faster, but I want to convey that there's a fundamental mathematical problem in this. Even if we're really fast, if we got really fast, there's still always going to be this coverage gap. We're never really going to provide ever, without the assistance of machine learning, the ability to generate test cases fast enough to cover all the functionality and features and risk in a product. If you look at fundamentally when a developer adds a new feature, right, it's very easy for them to add a new button or a new dialogue or something like that. But that dialogue or button, that state of that element can interfere or interact with other pieces of the application, right? So what that means is that every time one little feature is added or removed, it can impact the functionality of n-1 other features, right? So by definition, that's an exponential growth in complexity. So every time we add a new feature, it's a potential exponential increase in the risk in the product. The problem with testing is, even if we were testing kind of fast, we're only adding one test at a time, right? And even if you say, oh, well, I have a loop where I parameterize it and I use like 1,000 different emails, right, in this test case, you're still only adding 1,000 at a time, which is linear growth, right? So we have this fundamental discrepancy between the rate at which our developers can add features and risk and the ability at which testers have to, and the speed at which we can add test coverage. So the question is, how do we solve it? So let's talk about what's slow, right? And let's talk about how we fix those things with help. And there's a lot of, so it's early, right? But this is a first swag of how AI can start helping speed up our test automation development. And this isn't just like a lot of AI slides these days. It's not just like, hey, it could do this, it might do this, or whatever. This is actual real code that really runs using an AI-first approach to solve real-world automation problems and try to speed up the development, execution, and maintenance of test cases. So let's look at element selection, right? So a test case is fundamentally two different things. There's two different parts to most automation. One is identifying the element in the application for interaction. So if you want to find a button to click it, or you want to find a text box to enter a search query, and then find the search button to execute that search query. That's kind of the element selection part of it. It's also used for verification. So when you're at a part of your application where you're ready to check the behavior or the output, you want to find that element and verify that it's there or has the correct value or price, right? So element selection is a key aspect of test automation development. But if you look at it today, let's look at Selenium, and it's sad. I think the Selenium IDE, was even rumored. It's so old. I mean, it just looks old and painful, right? This IDE was, to find elements on pages, was almost deprecated, I think, a few months ago, but somebody else picked up maintenance of it. So this stuff is just really old, right? This is just old technology. If you look at it, it's pretty complicated. So this is connected to a website. You can see all the elements. But what you're doing here is you're manually looking at the application, and you're manually trying to find the thing that you want to interact with, and then you manually copy paste some selector string, some search pattern to find that element. That could be finding it by a magic ID, by parent-child relationships, by CSS selectors, and so on, right? So it's just a very manual process to make your test code aware of and be able to interact with any element. It takes time for every single element, and it's painful and an ugly process. So once you get that little magic string, then you still have to go back to make things worse and make things slower. You have to go write a bunch of code, and you have to copy paste manually, like we're in the 1950s, and copy paste that. Actually, I didn't copy paste back then, but copy paste that magic string that we got out of that Selenium IDE, or by inspecting the DOM in the browser, and you hard code that selector or XPath, whatever in this example, into your code. Right? It takes time. You got to write the code. Got to get the selector, you got to copy paste it in here, and then again later when the application changes or that button moves around, guess what happens? The selector breaks, and guess what you got to do? It slows you down. You got to go back to fix it. You got to go redo those steps again for every element that changed in your build to fix your code. And the worst part is, guess what happens? Your automation breaks. The one moment you really want to run automation is when the application changed, right? So the day, we all know this, the day they have a significant change in the application and we run our automation, guess what happens? And you know what happens? All of our automation breaks. And then we look at it and we go, yeah, no one trusts it because it's full of false positives and failures, because we've got to go update all these little magic IDs, which slows us down in test development, slows down the results, getting the results back to the team. And by the time we actually fix up all these selectors, guess what our app team's done? They've already manually quickly checked that the stuff still works, and they've moved on. So 3 days later, you've updated your code. Like, that's pretty slow. 3 days later, you update your code, and by that time you do that, nobody cares because they know it already works. So this is kind of a typical pattern in terms of automation on web and app teams today. But it's excruciatingly slow. And I would even venture to say it's even slightly embarrassing. So how can AI fix this, right? So what we're going to do, this is a very complicated, we need a lot of technology here, and it's non-trivial to kind of set up the infrastructure to do that, to do this stuff, but the good news is it's reusable, right? So we only have to do it once in the testing community. But the idea is, we fundamentally are going to do is we're going to teach, so how do we do element selection? We're going to teach the robots, these AI little bots, to go through, to automatically explore your application just like a human would, or as close as possible, just like you would as a human. Identify all the pieces and parts of the application, and then we're going to teach it to recognize all of those things. So you can name everything in your application very quickly, and let the automation actually, the AIs name everything in your application by default, and you can customize it. So we're going to find everything in the app automatically while we drink a coffee. The bots will find everything in your application, come up with a default name for everything, and figure out how to identify it. So how do we do that? What we do is we take a login screen, right, from this example. So how do we teach a neural network? We won't talk about the details of neural networks. That's like a grad level class in a fair amount of time. But we'll talk about how to use them and apply it to testing, right? So you can treat it like a black box. In this case, we have a sign-in screen. So what we need to do is convert the sign-in screen to, and actually we take a step back. We recognize it's a sign-in screen. Well, how do we know that as testers and as humans, right? So what we do is we look at it and we go like, hey, it doesn't have very many buttons. It's got 2 fields on it, and one's email and one's password. That's almost every single app that has a sign-in looks something like this, right? It looks very familiar to us, even though your brain hasn't seen this exact sign-in screen before. So how do we instill that same intuition and understanding with a neural network in a machine? So what we have to do is we have to convert. So our eyes take photons from the screen, and we parse it in our brain. We figure out that this is a login screen. But how do we teach a machine to do the same thing? What we do is we convert the screen into a bunch of ones and zeros that the neural network can understand. So we create a bunch of features, a bunch of inputs. In our case, for test.ai, we have over 250 of these. But we do things like we tell the neural network what the average color is of the screen, right? How many buttons it has, how many text boxes it has. Does it have a text box with the string password in it, right? And so on and so forth. And then we pass all that data, 250 different ones and zero, numbers between 0 and 1, for each feature, into the neural network. And then what we do is the neural network is randomized initially, right? It's a completely dumb, random brain. Then what it does is it makes a random prediction at first. It'll say, okay, I'm going to figure out, here we're trying to teach it like how to interact with this page and specifically how to interact with that hamburger button, menu button in the top left corner. So it's going to say, hey, at the top here, if you look on the right, it's going to say, hey, I'm going to try to do a zoom kind of gesture on the hamburger button menu. Well, we all know that's kind of a ridiculous, rarely done, used thing. It's not how humans usually use applications. So what we do is we say, bad robot. We say, dumb robot, try again. What it does is it goes back, and this is the magic of AI that we don't have time to talk about today, but it goes back and it changes around that network that you see there in the network. It just changes it around because it says whatever configuration I'm in now is not producing the right result, right? Then we try again and we try again. And finally when it says, hey, I'm going to tap, right? You say, good robot, congratulations, kind of operant conditioning style. And guess what it does? It says, okay, however my lines are configured in this neural network, it's a good one, right? This is actually, I'm doing the right thing, so I want to remember how I'm doing it right now. And then what you do is you do that across tens of thousands, even hundreds of thousands of elements and screens. And you have humans telling it with truth sets saying, hey, this is how you, this is what this thing is called, this is a good action to do on this page. So you can teach it generally how to interact with an application, but it takes hundreds of thousands of samples of input that are labeled, and it takes about 2 days, 2-3 days of compute on a really large machine with a lot of memory. But you can teach a little brain how to interact with the application. So what this does is it frees us up to let the robot, and not us, look at that application. So back in this world, what we're doing the equivalent of is we have to one by one find the elements in the application, find the little selector and all how to find that little element, and it's a manual process. And we only do this for the things that we need to interact with. In this case, we just give the neural network training stuff. We just give it the raw data, right? It takes a long time to create the data and training data, but now we can just sit back and build a brain that can walk through any application while we have a coffee, and it will go through the entire application, enumerate everything in that application, and give it all a label and a name, right? All automatically. So that speeds up dramatically what was a manual process, and even an incomplete process. It can be completely automated by machine learning today. Here's just a quick example of the bots walking through an application. So you'll see it sees at each screen, it identifies all the elements that are interesting with a blue box, and then it picks one to interact with, which is the green rectangle. This is real AI running on a real-world app and entering test data. So this happens, and the key thing here is that process now works for every application, which is the magic of AI. So just like your human testing brain can now pick up an app that you've never seen before, right? You can leverage all the training you've had of using every other application and sending into every other application you've ever looked at and understand, hey, these are the basic behaviors. That's a sign-in screen. Hey, I put my email into this one field, and the second field is usually a password. And by the way, my password probably needs to be, have a special character or something in it, because most sign-in or account creation dialogues, the password sophistication or complexity metric. So we do the same thing with machines, and we teach them that intuition. But interesting, we let them see about 10,000 to 30,000 apps, where you probably only played with, maybe a few hundred or 1,000 at the max. So the machines actually get better and smarter than we as humans in recognizing different parts of applications, like login screens or login buttons or search boxes or shopping carts. So then what do? So now we've trained it on a specific app. Here's just a visualization of how the brain is trained on different parts of an application. So we present it, present the element, the brain guesses what it is, and we say, yeah, check mark, good boy or bad boy, or good robot, bad robot. And it learns over time how to recognize all the pieces in your application. But again, that's done once, or for a specific application, you just label a couple things in your application and the brain learns it. So we've kind of skipped all this manual work of the past. So here's a screen. This is just I'm going to show some screenshots of our product just because there really aren't anything else out there that does this. But if you look here, here's a bunch of screens from Twitter, and the robots have suggested some labels, and which are those things with a little red box, little red next to it. So you can say, yeah, robot, you labeled it wrong. But by default, it already crawls a Twitter app. It can explore it, log in, do all this kind of stuff, and it will suggest labels and names for every state and screen and element in your application. And you can accept the robot suggestion, or you can just say, no, I call it this, and that's it. So it takes only about an hour and a half to go, at worst case, to go from an app you've never seen to let the bots crawl and understand the application, and then apply a couple of custom labels and accept the robot suggestions. So the entire process for labeling an application for automation takes about an hour and a half, where previously with IDE and Selenium stuff, that process can take days, and frankly, it's an ongoing process. So we've gone from hours to days to, with AI, that whole process can be brought down into minutes. Another interesting note to this is on the maintenance. So back in these Selenium selectors, right, if anything changes in that Selenium selector, its parent, it changes the class name, it changes the ID, those things break, right? And our test cases break, and it's embarrassing. You have to go fix it. So so it slows us down, right? We can't rewrite another test case or do another testing. We've actually got to sit back down, go back through manually update all those selectors. The beautiful thing about AI is just like your brain works. If the login button was blue and wide and on the bottom of your screen, but in the new build it's orange in the top right corner and it's tiny, the AI will still figure out that looks like a login button, right? It'll still recognize it and still be able to interact with that without breaking. You can tell the AI, hey, if it changes, let me know that's a failure. Or you can just tell the AI, hey, that's not the significant part of my test. I just want to sign in and get to the cart to do my testing. So if the app changes, it will still be able to sign in just like a human tester would on that new build with a change and get you to the cart to do your specific test verification steps. So what the AI means here is that you have far, far less of a maintenance issue with these things because the AI is adaptable just like a human brain. So the maintenance cost basically goes down from, for large test suites, it could be like 80-90% of your time at some point. But really, with AI, we can bring that maintenance cost down to near zero because we've made the bots think in the code and basically we're making the code as smart and approximates the human intuition to deal with changes in an application. So number two, the next major thing that happens that's slow today is creating. So now we know the things in the application. We now need to execute a test case, which is a sequence of steps, right? And each step is interacting with an element, measuring its value, and then doing these one after the other. But today it's pretty slow. Again, you have to code. If you don't know how to code, you got to learn to code. If you do code, then you're stuck in this world, right? Which is pretty exhausting for a full day. But you're not looking at the application, you're looking at code. And if you're looking here, you have setup code, a bunch of imports. You got to treat code like a project. I mean, there's like style guides, compile errors, runtime errors, and you have to like tell it exactly what to do. So that's the key thing here. To test the shopping cart, every one of these tests has to have either setup function or direct test steps to say, launch the application, right? Go in and enter the search text box, find the product element, add it to the cart, verify it's in the cart. You have to tell it exactly what to do in exactly the same sequence, the right sequence. So this takes a lot of time. This is why many teams, it takes, some teams can do less than a test case a day. Actually, most that I've encountered do less than a new test case a day. Some people get fast. They might add 4 or 5 tests a day. But this is pretty exhausting work. And again, just like element selection, if the application changes, right? So that's what else slows down testing. When the application changes the flow, or there's like a new dialogue in the middle of sign-in, right, that says, hey, congratulations, it's a Memorial Day sale. Click here to get the extra discount. That kind of thing will break traditional tests that are hard-coded in code because it doesn't know how to do it. It's looking for the shopping cart icon, but there's a dialogue that says, Memorial Day sale, and you want to dismiss that. So what happens with today is that it's really slow to write, and again, very slow to maintain these test sequence operations. And at runtime, again, this is just a picture of that. So at runtime, it's a hard-coded sequence. So the machine has no thought. It just executes exactly what you told it to do in the order you told it to do. And if anything changes in the app or timing or whatever, the app just breaks. So how do we slow? No, how do we slow it down? How do we speed all this stuff up? Right? This is just incredibly slow and expensive. So what we've done there's a lot of different techniques in machine learning, but this is one that we've see if I can get this to play.
Welcome back, Sepling here. You're watching.
I think people can see. Hope we can see. So what you see here is a neural network. We're training a neural network here on, actually, just go to full screen real quick. So what we've done is, this is a neural network learning how to play Mario Brothers. So this has happened, about a year and a half, 2 years ago. And the way it works is that Mario, like the robot, basically gets 1 million chances to play Mario Brothers, right? And it can randomly, each time it starts the game, it has default, there's a random inclination to jump or perform different actions based on different conditions, right? What you do is, the 90% of the Mario Brothers games it plays, this is Mario, by the way. What happens is, most of the games it plays, it walks into walls, or it just spins and does nothing and goes nowhere. But after millions and millions of iterations, it actually starts to learn how to play a near perfect game of Mario Brothers. So what they're doing here is, it gets points every time it gets a coin, right? It gets negative points every time it dies or takes a step. And it just, over time, it just optimizes to get a great score, just like a person, just like my kids would playing a video game, right? So what we've done is, get back to here, bear with me. Don't know why one second. So, blah, 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 blah. Okay, that's good enough. So basically what we've done is we've treated test cases as if they're a video game. So I thought basically, hey, like what we're trying to do is get the test case to like go to different parts of the game, execute specific actions, and verify that those things were good. So we really just borrowed this kind of a technique. It's called unsupervised learning, where you create this algorithm that knows that given the current state, what should I do next? You let it play millions and millions of times by itself, and it will figure out how to optimally accomplish a goal. So this is what we've done in Test AI in terms of test execution. This is a little complicated. It's like the world's most complicated, probably Rube Goldberg way to execute a test case. But what we do is we let, for every single step, so we want to go from the home screen, say, to the cart in the application. We've built a graph of the application earlier as it walked through the application, and we have labels for everything, right? And what the tester does is just define a sequence of labels. So I want to go from the home screen to the cart. And you can write that in a simple, we'll show you in a second, a little gherkin-style test case format, or you can just drag and drop in a GUI we have. But basically, you want to say, I'll go from the home screen label, and we'll go to the cart. And how do you do that, right? What we do is we have the app launches. The AI, if you look on the right-hand side, in the middle kind of here, AI does what we did before, which is breaks it down into something that the computer can understand, presents it to the neural network, and the neural network says, hey, in the first case, I'm in a home screen, right? And so it goes back into this little matrix thing. It goes, okay, so if I'm on the home screen, what's the next logical thing I should try to do, right? If I want to go from the home screen to a shopping cart, what would I do? And it'll say, hey, the obvious thing to do is click on the shopping cart icon, right? That almost always gets me there and gets me there fast. So we'll click the shopping cart icon, and voila, it lands at the shopping cart, right? And it can execute this over and over for every single test step that constitutes a test sequence. So you go, well, why do we make it so complicated, right? The reason is that you don't have to write code. The brain trains itself how to go from step to step to step in your application. But more importantly, if that application changes, so say on the home screen, the shopping cart button is gone, it's just gone, right? Classic test sequences in code would try to find the shopping cart icon and click it. Well, if it's not there, the test case breaks, right? And it's a false positive. What the AI will do, though, is it'll say, hey, since I've trained on this 1 million times, just like a human brain, on how to get from home pages to shopping carts in this app and other apps, I know there's another way to get to the shopping cart. I know that I can get there through, say, do a search for a product, click on an item, add it to the shopping cart, and then I'm in the shopping cart, right? Like literally I'm in the shopping cart. So there's multiple ways to get to the shopping cart. So if your test case doesn't care about how to get to the shopping cart, you just want to verify something in the shopping cart, say that it says shopping cart on the top. Just like a human, if that new build came out without the shopping cart icon, the AI will still go, okay, the shopping cart's not there, but I still know how to get there to check and verify that that part of the application is working correctly, right? And it will note that, hey, the shopping cart icon isn't there anymore. So what we've done is we've made it super fast to just say, hey, I want to go from A to B to C in my application. And the AI, that's all the human has to do. That's kind of the human intellect design of part of test design. The machine takes over all the parts of how am I going to get from A to B to C, and even if the paths change in the app, I can still get from A to C through D, right? It can find alternate paths to accomplish the test case, which means that day you have a new build and the flow changed, the AI will still be able to verify the shopping cart even if the ways to get there changed in the application. So that means you have far less time on test case maintenance and creation. You have far more time to write new tests and do other exploratory testing. So in this case, this approach to test sequencing changes the test case creation sometimes from weeks to create these long elaborate test type sequences to just hours, right? You just click, I want to go from A to B to C in the app, and training the AI takes about, locally on a MacBook Pro, takes only about a couple minutes, and then the AI thereafter can execute that test case on your app. So we've gone really a dramatic speed up from literally days and weeks down to hours and minutes, which means more test cases, more coverage, and the stuff works the very time you need it. Just like the AI on the first AI we saw for element selection, the Flow AI brings maintenance costs back down near zero. So like when that code breaks, when your app flow changes, your code breaks, you got to go update it, right? And that slows the entire process down. In this case, the AI just keeps going, right? It just keeps going. It's smart and can work around problems or changes in the application. Not around problems, but around changes in the application. So the maintenance cost comes back down near zero because they're basically self-healing, self-annealing test sequences. I can't hear anybody on the webinar, but I'm assuming there's a lot of clapping and excitement going on. So thank you. I'll just say that now. So let's get into the fun stuff. Really, really fun stuff. So that should be awesome enough, right? But the really fun stuff about AI and how it speeds up the world is reuse. This is something we've never really done in the testing profession. If you think about it, developers, designers, all that stuff, they reuse other designs, they reuse other libraries and functions and SDKs and stuff all the time, right? Testers usually start our test automation from scratch. We have an app and we open a new file and start typing some Python or Java, writing it from scratch. So AI, because it is abstracted from the application, can do some pretty awesome stuff. So today, the best of breed and the best of cases, like say an Appium or something, that code can run kind of cross-platform, right? Appium rocks, and it probably does. Everybody I talked to says about 60% of their test cases are reusable across platforms. So if you have an app that works on Android, iOS, and maybe the web, maybe 60% of those test cases in an ideal case, well written by a really strong team, are reusable because the flows are kind of similar across these different, for the same app across these different platforms. But what's interesting about these AI test cases is that we also can serialize them out into a gherkin style language, right? So humans could execute it, just like a machine, because the AI thinks like a human. You just need to tell it the test case in a human-like format. So this could be executed by a human. Remove Beanie Baby item from cart, right? Is a test case, right? You don't need to go into the details. This is very familiar. It's a BDD, TDD kind of friendly gherkin style format, right? Or cucumber kind of format, right? So people kind of always rock this, and humans can execute it. But the crazy thing here is that if you think about it, there is nowhere in this test case that says this works against eBay, or that it works against Amazon, or that it works against OfferUp, or that it works against any other shopping app, right? Or shopping app or kind of auction level app. So the beautiful thing is that if another app is labeled correctly, it has a label, it has the same things called search screen, a cart is a cart screen. The AI abstracts the test case from the implementation, which means that that shopping cart test can run across multiple applications. So that we've done that in our labs already, and we're expanding that out to like a large test suite here. But the beautiful thing is that that same test case that says add something to the cart, for instance, and make sure that there's one item in the cart and it's the item that you added, that test case can now be reused and rerun across any number of apps that have shopping carts and the basic flow of how to add an item to a cart and how to verify the number of items in that cart, because the AI takes care of all that work. So I think this is a pretty momentous change and opportunity in test automation, is that we only have to write the test case and some of the very general test cases once, and then we can share it amongst ourselves in the community and reuse those and re-execute them against our test cases, so we're not starting from scratch all the time. So how does that improve the speed of developing test automation? It's crazy, because actually the time to test coverage in the near future will actually be zero. In a weird way, it'll actually be negative time, because the test suite and the ability to execute that test suite against your app that you maybe just created this week was actually developed months before your app even existed, because your app has very common patterns and similar patterns to other, say, shopping apps. So this is a crazy thing where basically we're not just we get reuse, but that reuse means time to automation for an application can be as low as zero with using these machine learning techniques. So you're a new person, you drop onto a new shopping app that was created last week by a developer. You basically spin up the AI test automation framework, and guess what it has? It already has 30 test cases for shopping apps in there, and you just hit run, and it will run on your app and make sure those basic flows work without doing any work at all. So that's where we're getting, and we're getting there in the very, like I would say in the next 4 to 6 months, this will be demonstrable in production. So talk about speed up, right? We're going from like months, and that's even if you're successful, by the way, in test automation. You're going from months down to test creations times of days, from days and stuff to minutes. And then in terms of getting basic test coverage for an application, it's instant on. I mean, these things are just, it's kind of unheard of. But really it's all because of the power of machine learning and being able to teach a machine to think just like a person does, because a person can pick up an application and start testing it even if they've never seen it before, right? Just we're giving the machines the same ability that humans have. And that means that test automation's development and maintenance times drop to near zero. So lastly, I'd like to mention that, so how does this kind of work? Like how do we do this? I would just say collectively we're faster than any one of us. So if you look at the best test team on the planet, right, like whatever that mythical test team is, so they have infinite resources, infinite time, super experienced, like, you know, they're old like me and have, you know, 60 years of testing experience, test automation experience, and they've seen, I don't know, 20 apps, right, in their time. Like they're very promiscuous, they keep leaving companies, they learn lots of different apps and different techniques. That expert is nowhere near the expert as a machine learning system that learns from tens of thousands of apps or hundreds of thousands of apps and has the test cases from, you know, sampled from thousands of different testers, because we can reuse these artifacts and because the AI can run on many, many different applications. So soon in the near future, we'll have these AI test-based suites and automation infrastructure that has seen many orders of magnitude more tests, more failures, more apps, and then we'll have more experience than the best testers on the planet. So really what will happen is that we'll trust 80% of the testing to these generalized machines that will just do the automation for us instantly, instant on, and they'll be able to benchmark us against other applications, like are we faster or slower, are we buggier, or are we more stable, are we have the same feature set as the top apps in our category and our top competitors, and instantly, and then we as testers can take back our control and focus on the things that are specific to our app, right? The AI won't know how to do. So things like if we have a magic, you know, widget in our UI, right, that's unique to us that makes our app special, right? Or we have a unique flow in our application or some kind of creative content. We can focus on those aspects that make our app awesome and differentiate it instead of spending all of our time wasting all our time and slowing us down by focusing on the basic, you know, routine tasks, the sign in, sign out. Is there a shopping cart? Add something to the shopping cart, because it's been done before, and machines in the cloud will be able to do it for us. So collectively, the goal is to bring the more people that use such an AI system, we share the test artifacts, share that experience, share the training, share the labels, and these brains will be soon smarter than the smartest of any of us. Again, I sense cheering on the internet. I sense relief. I also sense some anxiety. We'll get into that in the Q&A. This stuff is real. The code runs, and it's demonstrable, and it's coming. So here's the one more thing people always ask: how can I get a lot more information on this stuff? So a friend Tariq and I have created a .org site. So anybody goes to aitesting.org. It's basically, it looks like a really professional, semi-professional website. Looks like there's a big organization behind it, but really it's just a few folks, and maybe 500 folks have signed up. That's a small organization for people focused on AI for software testing. And so sign up on the mailing list, and when we have events, meetups, or there's white papers and hints and tips and tricks on how to get started with AI for software testing, all that data will be collected on the site and on the mailing list. I'll add, yeah, we're doing a virtual conference next month focused on AI for software testing. And we have meetups like at another conference next week. We're all getting together, for dinner and just geek out on AI for software testing. Still a small community of actual practitioners. But if you want to keep up on the latest, this is the best way to do it. Also, a plug is if you want to get into AI and software testing and see what's going on, you just go to this website. It's awesome. The founder is a handsome man. Just sign up and we'll onboard you. In fact, we're able to write test cases for companies. We can build small test suites for companies that we've never met in less than an hour and a half. So if you're interested in getting AI running, and getting automation at all running on your app, like in a few hours, from zero to automated, or if you want to kind of play and see the current kind of bleeding edge of how AI is applied to test automation, you can talk to us and we'll get you set up and get you running with AI pretty quickly. And also, if you have any questions, I'm a geek and I'm lonely and a nerd, so if you have any questions or comments or flames, just send me mail at jason@testai, and I'm happy to respond. Just give me like 36 hours to get back without complaining. And also, like the nerd social network is LinkedIn, so you can reach me there at Jason Arbin. And I post some articles and post some more technical articles on machine learning and classification and so on and so forth, and some interesting AI-related developments up there too. So love to keep in touch. And if you want to be an AI nerd and focus on software testing, just reach out. That's it. That's all I got. Eric, do you want to flip it over to some Q&A, or should I just go through this?
No, absolutely. Thank you, Jason. Yeah, we have quite a few questions, so yeah, feel free to go ahead and address those in the Q&A panel.
Okay, cool. First question is, how are you so handsome? Oh, sorry, that's not a real one. Okay. We got, all right, element selection. So the question is, bear with me, resizing windows. What is the cost of training the neural network on developing patterns versus traditional automation process? In other words, what are the minimum rounds of data sampling needed in general before the AI engine starts identifying the elements? Okay, that's a good question. So I think basically there's really two phases. There's three parts of the machine learning training that goes on here. So the cost, I'm guessing the cost is, there's cost in terms of dollars, and there's cost in terms of setting up the training, and there's cost in terms of executing it. So the cost in dollars is actually just human hours. So, but it might take a month, 2 months to get a good, clean data set together and get some examples and get them labeled for training. So that's about a month kind of engineering cost, and maybe some, $2,000-3,000 worth of, maybe $5,000 worth of Mechanical Turk labeling costs. The cost of actually doing the training work is just compute. That's usually maybe 1 or 2 very large machines that run. The way we do it is single machine, and those run for about 36, 48 hours. They're the super deluxe, extra large machines at Amazon. But that'll take about 2 days of compute to run through, say, 600,000 plus elements, labeled elements. So that's in terms of compute. And then the last is when we personalize that kind of a one-off, kind of one-shot kind of learning. When we personalize the general brain that's trained on every app, just like your brain has been trained on using apps, we personalize it to a specific app for, for feature-specific issues on an app. That takes only about 180 seconds, sorry, a minute and a half of local compute, and that can run even on a MacBook Pro. So all this AI stuff can run on a single machine once the brains are generated in the cloud. We move those brains to a single laptop or Mac Mini, and that last mile training takes about a minute and a half. It's pretty quick. Next question is how AI engine develops context. As AI works on approximation to detect changes. So every time a new page is introduced in the app, do we need to retrain the AI engine for the page? It's a good question. Or will it figure it out by itself? Yeah. So the AI it's a good way to kind of a good description. It works on approximation. So it's almost like if you squint your eyes and you kind of blur your eyes, does it still look like that login button? Does it still look like a shopping cart? So AI works great at generalizing, right? So it can still interact with a shopping cart if it's different. Testers always go like, well, I want to know if anything changed, right? And the reality is that we also can do that with AI. So one is that the AI just explores the application, finds all the elements, and if anything precisely, any pixel changed or any element on any page changed was absent or added or morphed, there's a separate report that can spit out all those functionally different elements for the human to say, oh, okay, that's a legitimate change, that's not a legitimate change. But the goal of the AI, parts of the test case you hand over to the AI, is that it will keep going despite minor changes. But wherever you want to specifically verify it, we fall back into classic, is that the exact thing I was looking for, the exact string I was looking for, the exact element. So your verification can be as precise as you want, but let the machine do as much of the hard work as you want, as you hope. And then the second part of the question, so if every time a new page is introduced, do we need to retrain the AI? If there's a new page introduced, odds are probably today they're probably 50-50. If you didn't have a shopping cart before and you added a shopping cart, the AI will just know it's a shopping cart and keep moving, right? You don't need to do anything. And if you have a dormant test case that wants to interact with shopping carts, or like you did TDD, you wrote it ahead of time, it will now just be able to execute and automatically pass that test, which is pretty awesome. If you have a new page that's like I don't know, super random Wheel of Fortune, game widget or something that has never been seen on the internet or nothing like it has been seen in the app world, the general brain has never seen it, then yeah, you need to take, again, it takes just a second. It says, hey, there's something new. You go into the labeler and you just say super magic Wheel of Fortune widget, you give it a name, and then you can retrain in about 180 seconds, like I said, and then it will go on and be able to execute. The key notion of that is that all the existing tests that you have would still execute, right, even without retraining. But if you want to add the new thing add test coverage for the new thing that's never generally been seen before, you do need to go back in, but it takes about 5 minutes to load it up, label the new thing, just a picture of it, it says this is new, you label it, and then say run a regression. It takes 180 seconds. Next question, is if the application wants to add a step or screen into a flow before the shopping cart, i.e. we want to test specific flow and the new screen and not get to the shopping cart anyway, but rather than a specific flow, how would AI pick that up? Okay, I think this is back to the kind of original question, which is you can with AI, with his AI test definitions, specify every single step and verify every single step if you want. The power of AI, though, is that you really don't want to. So if you want to verify an exact sequence, right, you can do that, but you're kind of reverting back to the brittleness of Selenium, because if you hard code to that exact sequence, say you want to verify something in the shopping cart, but you don't care how you sign in, right, like for that test, if you can specify an exact sign-in sequence, but if you do that, if that sign-in sequence changes, the cart test will break, right? So you're kind of regressing back to the brittleness of a hard-coded Selenium style test case. But you can write those if you want. Next question is, from a tester's perspective, where is a good place to get started with AI, websites, books, etc.? Yeah, so I think we sent a quick email out to the AI testing organization, but I would recommend, there's a bunch of little places. One cool place is if you're kind of a programmer, you kind of code, is the best one is just type into Google, type in TensorFlow, I think it's getting started. There's TensorFlow getting started. Some awesome, WYSIWYG examples and tutorials and stuff to get started. And if you just have data, you can start plugging it in and start playing right away. If you want a general sense, particularly for management or a non-programming person who wants to get a good feeling for the capabilities of AI and what kind of pieces of AI would be useful for different types of applications, the best thing I can recommend is there's a YouTube series by Andrew Ng. It's NG is his last name. So if you just go, it's on YouTube. So just type YouTube, Andrew Ng, and then probably Stanford. And there'll be the Stanford introduction to AI classes on there. It's the best ever. Just don't worry about doing the examples. Just kick on YouTube, sit back, watch an hour a day. You can get done with it in in about 2 weeks, and you'll actually be able to sound legit in terms of talking about AI and knowing how it might be applied to things without being able to necessarily build it. And again, actually, like I said this already, the fastest way, it's not just marketing, but there's a few companies, there's a few startups trying to use, apply AI to testing. So the easiest way for a non-technical person to play with AI and bring AI into their environment is actually just to use one of these new AI vendors. So a couple of them, there's Nable, there's Sophie.ai, there's Apple Tools. Apple Tools is awesome in the cross-platform kind of visual world. There's a couple of startups, and then with TestAI. TestAI is basically TestAI is like we kind of walked through. It's a reimagining of and a rebuilding of Selenium and Appian kind of infrastructure, but with an AI-first approach to solve these problems with automation. So you can just get started, and again with TestAI, you can get started in an afternoon with this. You get automation. If you don't have any today, you end up with 10, 20 test cases by the end of the day. Where should one start to practice AI on the software they are testing? So again, you can use vendors and get those things up and running. That's why vendors exist, because they have the time and energy to build general solutions that work on specific apps. One of the best things I do, I guess, would say sit back and think about what kind of data you're measuring. So it really depends on the project, right? If you have a data-intensive project, it's different than if you have a UI-based project or if you have some kind of computational application. It depends on what you're testing. It's kind of, I would say. So I would actually defer people to you can email me if you have an idea. Just tell me what your application is and give me a quick idea of that. And if you ask, I can point you to different techniques that are useful. It's hard to give a general answer to that. There's even things like adversarial networks. There's a lot of the Go guys, the Go team is using. There's a lot of different techniques. So just email me and I'm happy to give you an answer, and I'm happy to also compile that and share that with everybody. It's a good idea actually over time. Does AI integrate with CI/CD or has no impact? Yeah, I think absolutely. So continuous integration, continuous deployment. The biggest problem is that, and I'll add to that agile, right? People shipping fast and continuously, is that those kind of teams don't have the time, like we're talking about here, it's too slow to write automation, so they just stick with manual, right? They don't have time to sit back, take a breather, and think about an automation suite and write those test cases. With an AI framework like this, you can create those test cases the day that the feature is added to the app, or you can even TDD style at the beginning of the sprint write the test case. So as soon as it's deployed and ready, there's a test case to verify it. We also technically, to prove that this stuff is just in real world connected up, there's a company called BuddyBuild. It's run by Dennis is the CEO, and he's awesome. Actually, Apple just bought them a couple months ago. But they will do your mobile builds in the cloud for you. They're CI/CD basically infrastructure for mobile, and they have an integration where if you just click basically one button, they can turn it on. You have to talk to them; they'll turn it on. But it will automatically post that binary that's produced immediately to either our cloud or to your local cloud and execute all the test cases and give you an email report. So it's this kind of AI stuff is deliberately and more interestingly appropriate for CI/CD world because it's super fast to add test coverage and it's super reliable and will run on every build. This person lies. They say they actually have one question, but they have two. Let's see. That was dorky. The actual question was, I have 2 questions. Are you doing a Q&A or should I just submit here? Submit here. Thunderous applause from Jonathan Beal. Thank you. Does it use Python and TensorFlow library? Yeah, so we use test AI stuff is implemented. There's a bunch of different ways to write this stuff. We use Python primarily, and we use like scikit-learn package, primarily because it's just an open source, very open kind of and very mature way to write these things. But we also are moving some of our stuff to TensorFlow. The TensorFlow is an open source way to kind of write and implement and share networks and from Google. The cool thing about TensorFlow, I would say the real thing motivating us for TensorFlow, it's a little revealing, but is that if you want to get AI running on, say, even a mobile device, there's a TensorFlow library for mobile. So if you write your stuff in TensorFlow, it will run either at crazy scale on the cloud, or it can run even as small as devices an iPhone. So we're moving a lot of our stuff into TensorFlow slowly, but we're moving a lot of it over to TensorFlow for those reasons. How do you deal with use case requirements that may differ from gherkin expected by the learning algorithm? Let me think about that. How do you deal with use case requirements that differ? I would say if there's use case requirements that are different from the gherkin expected by the learning algorithm, there's always opportunity. So AI basically is never smarter out of the gate than the humans that teach it what to do, right? So if you have a tester writing a gherkin style AIT test case that's not according to, that doesn't match requirements, it will functionally fail, which you can say, hey, you look into it, you go like, oh, we don't expect the product to do that, so remove that test or fix it. If the tester it's just writing stuff randomly, just like in the real world, that manual or automated test case will fail. There's no validation. There's no way that I know today that applying AI to verify the gherkin's correctness versus requirements. I would recommend, some teams are moving, by the way, some teams are moving toward a world where they actually write the requirements just straight up in gherkin, right? Like almost a pure TDD kind of approach. And I would actually recommend that if there's a lot of confusion in the organization between requirements and the actual kind of gherkin descriptions that would be fed to humans for execution or to AI or machines for execution. I call that an organizational, not a technical issue. Can you describe inputs to neural networks and how they are normalized to the 0 to 1 range? Yes, I should have said that. So when you basically present, back in our example, when we presented a login screen, what we tell the machine is that there's 2 text boxes on that screen, right? And so 2 text boxes are, if you think about it, when your brain looks at that screen, if I showed you a screen with only 2 text boxes, you'd probably figure out that's probably a login if you had to guess, but you wouldn't be very confident, right? The fact you see a couple, another button below it gives you more confidence. So the way we convert those things to a 1 to 0 feature to train the network is there's 250 different feature signals, by the way. So one is we just go, for number of text boxes, we take the general max number of text boxes an app will have on a page. So that might be like, I think the number we use is like 50. And we take the number that appear on the page and we divide 2, in this case 2, divided by 50, which, hold on, let me get a calculator out. What's 2 divided by 50, right? Holy bananas. Oh, holy bananas. Whatever that fraction is, we put that float number into there, right? So that's a 0 to 1 range. So it's going to be 0.04. So we'll put 0.04. I'm documented on this, aren't I? So we put 0.04 in for the feature named number of text boxes. For things like the average color or RGB value, we'll walk every single pixel, right? And add up in average the number of red, green, and blue components of that pixel. And then we simply divide that divide each of those numbers. We actually input it in as average red, average green, average blue, and we'll divide that by 256, which is like the max RGB, individual value of RGB numbers. So if it was, if it was 128, we put in a 0.5, so it would be 128 divided by 256 as a feature for the average green color on that element. And we have 250 other kind of calculations like that. That should help, though, in terms of how you write features to convert it's like a transducer really to convert the real world or this human representation into a network representation for training. How will AI work well in an IoT environment? So we've kind of been talking about how AI works for things with a user interface. Interestingly, most IoT projects that I chat with people about, they almost always have an end user. Most consumer, even commercial deployments of IoT have some sort of UI to let the person monitor or control or configure these things. So it would work just like any other app. If you look at microservices even, I'll add that into this mix, or pure API tests or kind of products, or if you have an IoT thing, it's just a device and it's working with no UI, just kind of operating on data and providing I/O. There's a lot of other techniques. If you email me, I'm happy to point you to some of them. But that kind of AI applicable to that stuff, or things like that will detect anomalies is very typical today. So they'll apply AI, which just looks at, you just feed the raw data that's coming out of it, for example, into, we'll talk about, there's different algorithms, but basically it'll look for anomalies, right? Because it'll automatically detect that, hey, there's a sinusoidal kind of output, or there's a weekly pattern with weekends, and that goes on. There's monthly cycles, yearly cycles in the data. You can train and say, hey, this is a normal, say, load, right, or a range of values, and then you apply it to the actual runtime value of that IoT device or microservice or whatever that's spewing out data, and it'll automatically alert you with no code, just training data. It'll alert you if there's any abnormalities, anomalies. I'm an abnormality. If there's any anomalies, it'll flag human for investigation, or it automatically shut something off, like if it might be a dangerous piece of equipment. If there's an anomaly, you just shut it off to be safe. That's mostly what I'm seeing in kind of the IoT and microservices world for applying AI.
Jason, let's make this the last question here.
Okay, cool. All right, you're tired of me. That's cool.
No. The next question. We got one more question, then that will be the last one.
All right, cool. Let me take 2 seconds and find a good one. All right, here's a good one. So how would you handle negative tests? This is a good question I get. So what we've done is we trained the bot to walk through. We saw earlier how to train the AI how to walk through an application like a normal user, right? Like a nice, happy path human would do it. But guess what you do? Just like you could, it's a bad example, but just like you can train a dog to be an attack dog, right, or a military dog, you can train it to attack. So instead of saying, good robot, you tapped on the hamburger button menu, right, or good robot, you did a swipe on the introduction screen, you can say, instead you say, bad robot for tapping or bad robot for swiping. You train the robot instead on training data that says, hey, I want you to do a double tap on the hamburger button menu, or I want you to enter a really, 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 really long string. If it does that, you say, good robot. That was a mean thing to do to the application. You just have to change the training set from training it to be a good soldier to being a mean bad soldier. It's just what the training data set is. And you can create separate brains. We don't do that today here yet, but it's on our roadmap is to create, we're building nice, good, happy path brains, but we'll be building a separate set of brains that do mean, negative, edge case things to applications. And you just run the different bots at different times, and you'll get positive, happy path coverage, and you'll get negative kind of edge case, negative testing coverage with the other bot brains. So that's it. I guess before we close up, I just want to say thanks to everybody for showing up. And this is the early days of AI for software testing. It's real. It's here. It runs. There's real companies and real paying for it, using it, and creating the software. So get on the bandwagon. It's going to change. This is the first technology I've seen in the last 15 years that will actually change testing significantly. Because AI is ripe for application to testing. It's built for testing because we as testers are emulating humans and human behavior. And guess what AI does? It's a way to teach machines how to emulate human behavior and human judgment. It's a perfect fit, and we're just at the beginning of a radical transformation in testing. Thanks.
Wonderful, Jason. Thank you for your time today, and I want to thank everyone for joining us for today's webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. Again, be sure to join us for the next webinar in the series, Accelerate Digital Transformation with Mobile Test Automation on May 15th from 12 p.m. to 1 p.m. Central Time. To learn more about this and other webinars in the series, go to testinginstitute.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day. Thanks again, Jason.
Cool. Thanks, Ben. See y'all.